This is programming in any language. You're working with C# right now, but the principles are the same in all languages. Master these principles and you can easily jump to any other language quickly. Behind me, you can see the basic flow of the if statement. The program flows logically from the start and enters what we call a Boolean expression. That expression is interrogated, and if true, the program branches to the block of code or single statement you see to the right of the Boolean expression. If the expression is interrogated to be false, then the block of code on the right is ignored and program flow continues below. You'll also notice that even if the block of statements on the right are executed, program flow still follows the flow beneath the Boolean expression. Basically, no matter what, the program is going to go from the start to the continue shown here. Whether it includes the statements to the right of the Boolean expression completely depends on how the Boolean expression is interrogated. Let's look at an example. What you're looking at here is our flashcard demo, which we've used in the past videos. I'm going to run this program real quickly to show you what we can actually change by using the if statement. If we hit start on this thing, it comes up briefly, and we'll go ahead and we'll actually put in a 10 in here and give ourselves 0 through 10 as our numbers. Here's our 2 divided by 3, and we get a remainder pops up. Notice it was blank before, and now it's popping up. To continue on this, 3 divided by 0. If we can't do division by 0, that thing's working still, and everything's fine there. 8 divided by 10 is 1 remainder of 2. And we do another continue. 7 divided by 10, 1 remainder of 3. And 7 divided by 5, we still have a remainder here. We're looking for one that doesn't have a remainder. And here's 0 by 0, we can't do a 0 division. Another one with a remainder. Another one, and we'll get them forever now. Here's one. Okay, 6 divided by 2 is 3 with no remainder. So why do we need to show this if we end up without a remainder in our application? We don't. And an if statement's going to be able to get rid of this for us. That's so we can use it. So let's go ahead and close this program off. And let's go into our code. We're going to go into the division code right here. So I'll double click on it to get to that division code. And we see it right here. We don't care much about the catch statement because that's all set. It's going to run. But we're looking at the try. And if the try is accurate, we're going to end up with a remainder right here, which we'll set up as our variable. And we'll go ahead and do the calculation. And the remainder will actually get calculated. Now, if the remainder is not 0, it's got a number in it of some kind, we can turn on these things, these 2 labels. Otherwise, we don't have to. Those labels are, of course, if we look at them real quickly, they happen to be this one right here. If we look at it, it's called LBL remainder 2, and this one is called LBL remainder. So if we turn those off, we simply won't see them. The user will be fine. We don't care if it calculates. That's not a big deal. So let's go to our code. If we go here and create an if statement, we simply have to go if. Then we use a parentheses to put in our statement, our Boolean statement, our Boolean operation we're going to actually put in. We'll put down int remainder is greater than 0, which is perfect. And it creates a block of code for us right in here. And I'm going to enter on this. And what it does here, this is the Boolean statement that's going to be checking. It's going to say if int remainder is greater than 0, it's got a number in of some kind. We want to go ahead and we want to run whatever is inside this block of code right in here. What's that block of code going to be? Well, it's going to be this. We're going to take these 2 labels, pull them out of here, and put them in here. And then shorten this up a little bit. And now, these 2 labels are only going to become visible if the remainder is greater than 0. That's all we have to do. Let's clean this up a little bit. There. Now we can actually go ahead and save this and do a run. Now let's see what we get. Our program is going to come up again. Again, we'll give it a 10. So we'll calculate from 0 to 10. 6 divided by 0, we're going to get a division by 0 right away, which it's not going to do. So we're going to try something else. 5 divided by 3 is going to give us a remainder. That's working just fine. And 3 divided by 3 is a 1. No remainder. Notice that it didn't pop up here. Now, did it stay off that way, or will it still work the way it did before? We do a continue. Get a 10 divided by 1. Again, a 10 with no remainder. Continue. 0 divided by 10, that's a division by 0. And finally, another division by 0. A 3 divided by 1 is going to give us a remainder, so it does work. So the if statement takes those 2 labels we don't want to see when there's no remainder and makes them disappear. It only execute that code if the remainder is greater than 0. That's all you got to do. Pretty simple, eh? It really is. And back in the day, this and the if-else statements were the only tools you had to branch off in another direction with your code. You found this stuff in COBOL and Fortran. Today, it's in every language, along with other tools to make decisions easier, and we'll see all those coming up. Prior to COBOL and Fortran, you were probably using the assembly language. If you needed to branch somewhere in assembly language, you would use actual branch statements that move the contents of registers around the CPU. Quite confusing and time-consuming as well. It was quite an involved process. Now about that Boolean expression. In the video, you saw the greater than symbol being used. That's not the only operator you can use. There's actually 6 of them. There's equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. That's 6 operations. And you would use any one of them in the same way you saw the greater than symbol being used in the flashcard demo. They look easy, and they are. But they can be tricky. It's always a good idea to test yourself with this Boolean logic so you know your program is going to work. Okay, let's run a little test just to get an idea how these operands work. Looking here, we've got a comparison right here of 5 is set equal to 5. I like to call this set equal to 5 rather than 5 equals 5, but it's set equal to 5. Is that true or false? Well, 5 is set equal to 5. This would be a true. So we can just put down true here, and we'll be in good shape. How about 6 is set equal to 5? Well, that's obviously false. So we'll just put down a false here and set that in place. Next, we've got 5 not equal to 5. This might take a little bit of thinking. 5 is not equal to 5. Well, 5 is equal to 5. So if 5 is equal to 5, the not equal makes this thing false. Because 5 is not equal to 5, 5 is equal to 5. So it's a false statement. 5 is not equal to 6. Well, that's a true statement, right? 5 is not equal to 6. How about 5 is greater than 5? No, it's not. 5 is not is actually equal to 5. So 5 is it's going to be a false statement. How about 5 is greater than 6? That too is a false statement. 5 is less than 5. That's going to be a false statement as well. 5 is less than 6. That'd be a true statement. Because 5 is less than 6. 5 is greater than or equal to 5. Think about this one. 5 is greater than or equal to. Well, it's equal to. So if either one of those is true, it's going to be a true statement. So this is going to be a true statement. It's equal to. 5 is greater than or equal to 5. True. 5 is greater than or equal to 6. Well, that's going to be a false statement. How about 5 is less than or equal to 5? Again, we have the equal sign and the less than sign here. 5 is less than or equal to 5? Yes, it's equal. So it's less than or equal to? It's true. And finally, 5 is less than or equal to 6. That also is true. So that's basically how these operands work. As long as you understand the differences and go through them and think about it when you actually do this thing, you're going to be fine with these things. They'll work out just fine for you. Okay, so you can see that these Boolean expressions are easy, but maybe a bit confusing when you apply them to your program. Down the road, we'll investigate how they could possibly get more confusing and how you as a programmer can take steps to always make sure the logic of your program is correct. You'll see that in the upcoming videos. What you need to take out of this video is, number 1, the structure of the simple if statement. And number 2, Boolean operators. We'll see you next time. Thanks for watching. If you get a chance, please subscribe. We'll see you in the next video. Take care.